Yeah. Hello everyone, welcome back to another important video of the data structure and algorithm series. I hope you are doing well. So let's start. So now the today topic is binary search. So binary search, let's understand what is binary search. Binary search is an efficient searching algorithm for finding an element in a sorted array. So before binary search, there is another searching algorithm, which was a linear search, in which we have to search a specific element linearly, one after another. So, let's talk about brief about the search. So in that case, we have to iterate each and every element to find a target value. So the worst time complexity in the linear search is that order of log n, where n is the number of element in the array. So now come to binary search. So to overcome that time complexity issue, the binary search comes. So binary search is a very uh, efficient way to find a specific element. It works by repeatedly dividing the search interval in half. It is much faster than linear search for the large data set. So what is the there is some prerequisites of binary search, which is the first one is that input array. The given array must be in a sorted order. Because binary search use divide and conquer approach. The main key concept of binary search is that it compares the target with the middle element, and based on that it will shift, it will shrink the complete array into a half. So let's understand how it's happened. So there is a step by step. Let's take and understand one example. There is an array given which is 5, 9, 12, 17, 23, 29, and 31. And there is a target value is 23, which we have to find in the given array. The first step, as the given array is sorted, okay, it means that we can implement the binary search. Now the first step is that we will take two pointer, low and high. Now after that we will find the mid value, which is the formula to find the mid value is the low index plus high index divided by 2. Okay, got it? So let's understand here. So array of 3, let's find out the mid. So now the low is 0 plus 6 divided by 2. Now the mid is 3. So at the array of 3, we will get the mid value is 17. As the mid we got is 17. As 17 is less than 23, it means that the target value might be present at the right part of the after 17. So what we have to do, we will uh, update the low index. Now the array will point, now the low will point mid plus 1, which is nothing but the index 4. Now again we repeat the same step. Again we will find the mid. So now the mid is now the low plus 4 plus 6 divided by 2, which is 5. Now at the array of index 5, the value is 29. 29 is greater than 23. So it means that as the 29 is greater than 23, it means that the target value might be present at the left sub part, at the left places from 29. So what do we have to do? We have to update the right index, means the high index. Now the high will point to 5 minus 1 is 4. And the high is pointing 4. Now again we will repeat the same process. We will find the mid another time. So now the low is 4 and high is also 4. So 4 plus 4 divided by 2 is 4. At the index 4, the value is 23. It means yes, we found the mid. We found the target element. So in that case, we will return its index. As simple as that. So this is how binary search actually work. So let's understand its pseudocode, how it happened. So there is a function okay, one is binary search. We have taken one function. The name is binary search, which will take two arguments. One is the array, and second one is the target value, which we have to find out. And this function will return the index of the target element which present in the array. So now we will take two pointer as we have discussed, low which will point to initially at 0 and high which will initially point the last index of the array. So let's understand while let's execute the loop while low is less than equal to high. Now we'll find out the mid. Low plus high divided by 2. If let's for the first step we will check either the at the middle place means at the mid index is equal to target. If the middle index value is equal to target, so in that case simply we will return the middle index value. As we have discussed that in the first case we will not find the middle a target value at the middle place. So what will happen if at the middle index value is less than target value? So in that case, we will update the low pointer. Now the low pointer will point to mid plus 1. If that at the middle index value is greater than target, as we in the next case as we have discussed here, like 29, which is greater than 23. So in that case, what will happen? We will update the high pointer. Now high pointer will point to mid minus 1. So this will execute until we will find out the mid. We will find out the target value else, or the low pointer is less than equal to high. So there will be some scenario where the target element is not in the array. So in that case, we will simply return -1. So now let's understand the time complexity about the binary search. So in the best case where we have to perform only one operation, like at the first calculation of the mid, if the target element is in at the mid of the array, so in that case we have to only perform one operation. In that case, the time complexity is order of 1. If in the average and worst case, the time complexity is order of log n. Why? Because we have to perform as the each time we are dividing the complete array to two part, and we completely eliminating the one part, and we will search on the another part. So due to this, the time complexity of the average and worst case is order of log n. Because each step reduce the size of the complete array by half. Now let's talk about the space complexity. So if we implement the binary search in an iterative way, so in that case, the space complexity is order of 1. Okay. While if we implement binary search in a recursive approach, so in that case, the space complexity is order of log n. Why? Because as in the recursive approach, we have to there is a stat used in the background. So due to stat, the space complexity is log n. So there is a one of the most important advantages of binary search is it is very fast and efficient to find out an element or target in a large sorted data set as compared to linear search. And it requires only log n comparison to find out an element. It is efficient for the static data, but there is some limitation of the binary search. The first and the most important limitation is that binary search only work on a sorted array. Now the next limitation is that binary search is not that much suitable for the frequently changing data unless it is resorted. So if the data is in dynamic nature, means it is frequently changing. So in that case, the binary search is not that much efficient. So yeah, that's all about the binary search. If you talk about the real life example, so they generally use search in a dictionary, like auto session in search engine, as well as it also used in database indexing, gaming, etc. So that's all about the binary search and about its complexity and how it is more efficient and fast to calculate to find out the target value in a sorted array. So that's all about for this video. Thank you so much for watching it, and I will come back with the another video. Thank you.